Okay, hello everyone. So today we're going to solve this LeetCode problem 63. The name is unique paths 2 and it's the second variation, and if you want to well, there's a first variation as well which has the name as unique paths, only unique paths or unique paths 1. If you want to check that problem solution, then you can follow a link in the description. So now, as of now, we're going to discuss this problem. And it's a pretty standard problem, let's say, and it's a medium level question. Let's see. And one thing more, for interview standpoint, this problem is very standard and is actually observed that this problem has asked in a lot of interviews. So let's see. You're given an m cross n integer array grid. Okay. There is a robot initially located at the top left corner, which means that if this is the grid, then the robot is located at this point. That is the top and left corner. That is grid 0 0. Right, this is the 0 0 point. And the robot tries to move to the bottom right corner. Okay, so this is the goal, this is the start, and this is the goal state. The robot can only move in either down. So if this is the robot, it can only move in either down direction or right direction at any point of time. An obstacle and space are marked as 1 or 0 respectively in a grid. Okay, I think this one is a variation in the second part. In the first part, as you can remember, there were no obstacles, but in the second part, there are obstacles which are specified by 1. So, a path the robot cannot include any square that is an obstacle. Okay, which means that if we are following, let's say we are following this path, and this path should not have any obstacle. Let's say that there was an obstacle in this case, so this path cannot be followed, and because of that we have to follow another alternate path, that is this one. So let's see. Return the number of possible unique paths that robot can take to reach the bottom right corner. Okay, the test case, well, let's see. I think this problem could be better understood by analyzing an example. So so this is the robot, this is the start position of a robot, and the robot wants to go. Yeah, and this is the start position, and the robot wants to travel to this one, that is the goal state. And it has a lot of paths. First of all, the robot can go in this way. This is the first path. Then robot can also go from this path as well, right? But sadly, the robot cannot go from this path. Can you answer me why? Well, obviously, because there's an obstacle. Let's say, because of better understanding, the example has shown that the obstacle is like a rock or a boulder which cannot be passed. So, because of that, the robot cannot go from this direction to this path because there's an obstacle. And the robot also cannot go from this direction to this direction because there's an obstacle. So, there are only, well, this is not just one path, there can be multiple, but as of now, as of what we can observe, there are only two paths, right? And I think it makes sense because any other path, none of the other path can be followed because there's an obstacle in between. So this is the problem. So one naive solution to this problem could be that you are at your 0 comma 0 state, and now you have two decisions. And why you have two decisions? Because the question specifies that you can only move, uh, where was it? Yeah, you can only move either down or right, which means that you can only move in this direction, that is the right direction, or in down direction. So let's say you are at this block, so you can move in this direction or in this direction, although we cannot move in the right direction because there is an obstacle. But what I want to say is that the freedom to move is only two cases, that is either you will go in the cell that is below the current cell or the cell that is on the right of the current cell. So now you have two options. So from 0 to 0, Let's say I'm going to mark each and every. This is 0 comma 0, this is 0 comma 1, this is 0 comma 2, this is 0, so 1 comma 0 and 2 comma 0, and this is 1 comma 1, 1 comma 2, 2 comma 1 and 2 comma 2. Let's see. So if you are at 0 comma 0, you have two options. So the first is either you can go down or you can go right. So if you go down, then you will end up at 1 comma 0, right? So now at 1 comma 0, you have two options. Either you can go down or you can go right. Well, you will go down. So you have 2 comma 0. And at 2 comma 0, either you can go down or you can go right. Well, apparently the down is not possible because that's like an out of the boundary of grid. So you will backtrack to it and then you will follow the right path, and the right is 2 comma 1. And again at 2 comma 1, either you can go down or you can go right. Well, the right is not valid because then you will out of the boundary of grid, so you have to backtrack and choose the right one, that is 2 comma 2. And now the cell or the value, that is the cell that we are currently on, is 2 comma 2, that is the goal state. And because we are on this cell, so I will say that the path is now following this direction, right? So let's see what is the path. So you traveled uh, yeah, so you traveled from 0 comma 0, then you went on to 1 comma 0, then you again go to 2 comma 0, and then 2 comma 1, and then finally 2 comma 2. So this is the path. Let's see. So 0 comma 1, okay, 1 comma 0, okay, 2 comma 0, okay, 2 comma 1, okay, 2 comma 2. Well, that's a valid path. That's very great because we have completed a valid path. Are there any other paths as well? Well, of course there are other paths, and we have to return, if you remember, we have to return the number of possible unique paths that the robot can take to reach the bottom right. So this is one of the unique paths that we yet has to that are yet to be calculated. So let's see. Yeah. After backtracking this, right, we are done with this. Then we are done with the 2 comma 1, and now we are done with 2 comma 0, and then we'll backtrack to this one. So on this part, we will see that we have to reach the right part. So at 1 comma 0, the right is not possible because there is an obstacle, so we are not going to continue it. Then we will backtrack to 1 comma 0, sorry, 0 comma 0, because 1 comma 0 is also completely executed or completed. The control has been followed to the end of the function, so now we are back to 0 comma 0. And at 0 comma 0, we have the choice to move down or right, and we have used the first choice, that is to move down. Now we will move right, so we will move 0 comma 1, right? So now I'm moving in this direction. Now I'm moving in this direction, just remember it. And from this choice we have, from this point we have two choices again, that is down or right. And I will say that I will go down. Well, I cannot go down because 1 comma 0, then we have 1 comma, from 0 comma 1 we have, in downward direction we have 1 comma 1, that is an obstacle, so we won't be traveling here, right? Because 1 comma 1 is an obstacle, so we won't be traveling here, we won't be traversing this cell. And then I will say, okay, if I cannot go down, then I have the other option, that is right. Let's see. Then I will go 0 comma 2. Well, yeah, it's not an obstacle, so we can go to this one. Then at this point I have two options, that is either down or right. So I will say that yeah, I will say I will go down. Let's see, 1 comma 2, okay. And then I have another option, that is down or right. I'll say I'll go down again, and 2 comma 2. So we have reached, again we have reached a goal state, and now we have another path, that is this one, right? This is the another path. And if you're wondering what's the path exactly, this is the path. And then I will backtrack to 1 comma 2, and then I have to take the right one. Well, I won't be doing this because it's an out of bound thing. We are going out of the boundary of the grid, and that's not acceptable. And then at 0 comma 2 we cannot go right because that's an again an out of boundary option, so this won't be done as well. And now we are done with our question. So I can say that I have encountered 2 comma 2 two times, which means that we have two unique paths, right? And that is our answer for this example. Well, if you can understand that this whole scenario is going to take exponential time, right? Because we have a whole recursive tree that is forming up and we are traversing each and every possibility. And if you will also look closely, you can see that there are some overlapping problems. Let's see. Okay. Yeah, so let's see. Do we have any overlapping problems or not? Um, Actually, in this case, we don't have overlapping problems because the paths were very different, right? Like this 0 1 0 and then 2 0 2 1 2 2 is a whole different path, and this one is whole different path. But believe me, if you will take another example, let's say that we have 5 cross 5 grid or 6 cross 5 grid. In that scenario, if you have multiple or just one obstacle in between, then you will have multiple paths that are overlapping with each other. And in that scenario, you can easily conclude that there are some overlapping paths. The paths which are using same cells, like two different paths are using some same set of cells in their path, in their trajectory, which is like an overlapping problem. And when a recursive problem is an overlapping problem, in that scenario, we have an optimization technique for this whole case, that is DP or dynamic programming, right? We have dynamic programming for this one. Let's see how we can solve this question with dynamic programming. And by the way, for this solution, the time complexity will be 2 raised to power n, where n is the number of cells, which is n cross m, right? So this is the time complexity, which is very, very, very slow, and it's not acceptable in interviews or any case like that. So we have to come up with some optimized solution. And the optimized way is, let me copy this diagram or image. Yeah. So the optimized way to solve this problem is to keep a track of how many ways do we have for each and every cell. Let's see, at this state, at the starting state, how many ways do I have to reach a cell? Like how many ways do, like um just a sec. Yeah, I'm back, guys. Sorry for the interruption. I had something very important to do. So yeah, at this starting cell, that is 0 comma 0, how many ways do I have to reach this cell? Well, only one way, right? Only one way. So I'm going to say that we only have one way. And for this cell, how many ways do I have to reach this cell? Only one way, because I can only reach from this cell, right? And for this cell, how many ways do I have to reach this cell? I can only reach from this side, so only one. And similarly for this column, how many ways do I have? Only one and one. It's pretty easy to understand that you can only come to this cell from this cell, right? You cannot come from this, right? Or well, it's an obstacle, so you won't be there, so you cannot come from this side, and the direction is also not acceptable. And you can also not come from this side because it's an out of boundary situation. So now you understand that there is only one way for these the first row and the first column of the grid. Now for this one, well, let's say that there is not any obstacle as of now. For this cell, you can actually reach from, yeah, so for this cell you can actually reach from this side, right, and also from this side. But the ways of reaching this cell is going to be dependent on the ways the previous cell, the like the cell from which the cell, like this is a new cell and you are coming from this cell, or you are coming from this cell, then this cell is going to ask you that if you are coming from this cell, how many ways were to there to reach this cell. If there were, like x amount of ways to reach this cell, and there were y amount of ways to reach this cell, then in total for this cell it will be x plus y. It's fairly simple that if you are reaching from, like there are two ways to reach this cell and there are three ways to reach this cell, then to reach from this cell there will be like this, the ways to reach this cell will be x plus y or 2 plus 3, that is 5. I think it I am having some trouble explaining it, but for me it was very trivial and intuitive. I think if you can, like, try to wrap your head around it, then you will be also able to understand it. So for this cell as well, the dependency of this cell will be only from this, only from the cell that is above to it, right? So it's only one, it's again one, and the ways to reach this cell, only this cell is resultant of providing the robot a way to this cell. So the ways, that is okay, one only. And now if you want to reach this cell, then this cell is going to contribute in the ways of reaching this cell as well as this one. So the total answer will be 2. And now this problem has been reduced to order of m cross n time complexity. And again, the space complexity is, the auxiliary space complexity is still constant, but the time complexity is optimized to m cross n, and the previous time complexity was 2 raised to power n cross m, and now it's m cross n. This is the power of tp. So let's see how we can code this question. Okay, so first we have to keep a check that if there's an obstacle on the starting of the grid, where a robot has to start, then it's obvious that we cannot go in any other direction, because if this is a grid and there's an obstacle at this point, then we cannot go from this side or this side either. Even if there are no obstacles in the whole grid except the first cell, we still cannot move from that cell because we have an obstacle there. So this is the first check, that if there's an obstacle on the first cell, then we are going to return 0. And then we're going to say that number of ways, so this is not, I'm saying that there's an obstacle, this is not saying that there are number of ways of reaching 0 comma 0 cell, right, and that is 1. Then we are going to fill like the one I have shown you here, because if you can observe, then I have started filling this side, this row, and then this column, that is the first row and first column. We're going to do the same. So this is like first row, and this is the filling of first column. Okay, and the filling is kind of dependent on the fact, if you have um yeah, so if you have 0, if there's an obstacle, so if there is not an obstacle, like the filling will be done on two things. If there's not an obstacle and the previous cell has one way, then we are going to assign 1 to it, right? Otherwise there are 0 ways. If both of these, any of these conditions are violated, then we are going to say that there is no way to reach this cell, right? And why we are checking the previous one, because this previous one does not means that an obstacle, it means the number of ways, means the number of ways, although it's I think kind of confusing to actually have number of ways and a numeric value for an obstacle. But well, this is a question, and I think it's more like an intuitive question. So because of that, the previous one, that is I minus 1, means the number of ways. And then we are filling the first column with similarly like the we have done earlier on the first row. And then the main part, where we are traversing the whole grid, obviously not from the starting column, that is 0 comma 0 cell, from 1 comma 1, because we have filled this one, we have studied this one. Now we'll be starting with this cell and going in this direction and traversing the matrix this way. So yeah, so now you have, if it's not an obstacle, it's a clear path, then I'm going to have the value, that is the cell on the, like this one. So this is like 0 comma 0, 0 comma 1, 0 comma 2, 1 comma 2, 2 comma 2, and 1 comma 1, 1 comma 0, 2 comma 0, 2 comma 1. So if this is the, for example, let's say this is the ith I comma jth cell, then this one is the ij minus 1 minus 1, right? It makes sense because 2 minus 1. And this one is I minus 1 j, jth cell. This is the same thing that we are doing. The cell that is on the top or right above the current cell, and the cell that is on the left of the current cell, right? These are these two values interpreted to, and their sum, the number of ways for reaching the cell that is right above of the current cell, and the number of ways of reaching the cell that is on the left of the current cell, is going to be the result. Their addition is going to be the total number of ways to reach the I comma jth cell. And if it's an obstacle, then there is no way to reach that cell. Then we cannot even include that cell in our path. So we have to say that 0, there is no way, there is 0 ways to reach that particular cell where there's an obstacle. And now at last, as I've shown you earlier, we are going to have our answer at this point, because we're going to traverse this matrix from this side, and then from this side, and then from this side, and the last cell will be the goal state, and then our answer will be on the goal state, that is grid minus 1, that is the row or the last call number, and the last row number. Or it can also be n minus 1, or if it's an, yeah, it's an m. Okay, so it's like m minus 1 and n minus 1, right? I think the question is clear. It's not that difficult question, pretty standard question in DP. And if you can work around with this one and try to build another case or example by yourself, which is of more size, the matrix size is like 6 cross 6 or 5 cross 5, then you can easily understand that there is some overlappings, that this state has been explored earlier, but somewhere in the left, in the right subtree, you realize that there is 1 comma 0 again, and that's like a problem of overlapping. So then you will be like, okay, DP is used. And when you're going to use DP, then you're going to work your head around why like number of ways to reach this cell is the number of ways to reach, let's say ith I comma jth cell is very much dependent on the cell that is one above it, that is I minus 1 j cell, and the cell that is on the left to it, that is I comma j minus 1 cell. And when you realize and make this observation, then you will easily be able to write this code, and this part will be very easy to interpret and dry run your test case. So I hope the problem is a little bit clear, and this was it. Thank you for watching.